So our last little bit of notes here is talk through a word problem based on the idea of constructing a elliptical arch in the stone made out of stone for a fireplace. And so as you read through it, it says here the opening is 2 feet high at the center and 6 feet wide. So I'll just visualize that real quick. The contractor draws an outline of the ellipse and then uses 2 tacks at the foci and a string to create a template. Now let me just talk about the template design for a little bit. So first of all, this stone that's in the arch cannot just be placed in there with like a stone and mortar. It would not dry fast enough. This stuff would fall. So the reason the contractor needs to create an ellipse and create a template is there's got to be a structure actually that would have to be inserted, a wood structure, pushed back into this space, and then a 3-dimensional structure, and then the stone put in, mortared, and once it dries, knock out that structure, and now you've got your fireplace. So to make a template, and how the string idea works, I'll explain in a second. But going back to earlier in the notes, we had this idea that the focal point, from one focal point to a point on the graph, and from that same point to the other focal point, if you add the 2 blue lines together, would equal the distance of the major axis. Well, the way that the ellipse is drawn, I'll show you, and then we'll know why that major axis length is important for this, because we're going to create a string. It says, what's the length of the string? He's going to tack a string down. What string are we talking about? These blue lines actually together is a piece of string. So let's see how it works. So the idea would be that you would measure your major axis, which is going to be this point to this point. We're not going to worry about the compass here. That's just marking the focal points. And what you'll notice is what's going to happen is you'll see the string sitting out here at vertex to vertex basically, and then it's going to shoot into where the tacks are because that's the string length. The string is, here we go, string, boom, tack it down. Stretch it out with a pencil and you can make your elliptical arch or make your elliptical pattern. So as long as you know the major axis distance, in this case the span of the arch, you'll know how much string you need. So that's actually the easy part. So whatever that distance is, that's automatically your string length. Then the tacks. Well, the tacks are placed at the focal points. So I guess I need to know what foci are. Easy enough because I can actually determine what I would do actually is probably take a piece of plywood, maybe like a 6x2 or an 8x4x8 sheet of plywood, and I would center it, find the center, right? So I would go like halfway, make a mark, halfway, make a mark, find my center, and then from my center I can measure out the focal distance, place tacks, grab my string, 6 feet, stretch it out tight, and start to make my ellipse. So that means you got to calculate the foci, and that's a c-squared equation problem. So now what I'll do is from the center, I will go out on my template. I will place tacks at square root 5. Square root 5 is a distance. With my 6-foot string, stretch it out tight, put my pencil here, and back and forth, make a sketch. Okay, so just one kind of simple but useful idea that's behind the application, that's behind the idea of this relationship. And that's the end of the notes.